Well, hi guys, here we are again, and today in this session we're going to do, wait for it, we're going to do the antiderivatives of e to the kx. Now this is a nice short little video because it's really easy, okay? So we've progressed along, we've done general antiderivatives of x to the n, we've done antiderivatives of ax plus b to the n or to the r. We've also done antiderivatives of 1 over x or 1 over ax plus b, which is a loggy one, and here comes the e to the x ones, okay? Now this is really easy, so you don't need to fasten your seatbelt today. It's because it'll be too short. So we know, guys, that if y equals e to the kx, dy dx equals k times e to the kx by virtue of the chain rule. Isn't that right? So therefore, what I'm saying to you guys is, if you start off with dy dx equals e to the kx, you will know, basically, by putting a compensating 1 over k in there, similar to what we've done in earlier examples, you're going to get that expression there for the antiderivative of e to the kx, okay? And that is 1 over k e to the kx, and therefore the antiderivative of e to the kx with respect to x is 1 over k e to the kx plus c. That's the general case. And Mr. Box, thank you. Now that's all the learning today, guys, in this one. It's very, very easy. So let's do some examples, okay? Right, example A, we've got e to the 4x antiderivative of, okay? So come on, you do it. That's right. It's 1 over 4 e to the 4x plus c. Thank you, Mr. Box. Now this next one, they've mixed it up with a polynomially one, okay? E to the 5x plus 6x. So antiderivative of that is just going to be, what is it? Yeah, it's 1/5 of e to the 5x plus 6 times a half of x squared from a previous lesson plus c. Yeah, and I've just cleaned it up a little bit, and there's Mr. Box coming again. Thank you, Mr. Box. Get it? Now, what's this next one? E to the 3x plus 2. Yeah, we've just got a constant. They're trying to get us to remember whether we know what to do with the constant when we integrate it. So that's the antiderivative of e to the 3x plus 2 with respect to x. It gets us 1/3 of e to the 3x plus 2 times x and plus c. There you go. Okay, isn't it good? Now here's the fourth one. They've thrown a negative exponent at us, but we're not worried. No problem, because you see that e to the negative x, that's just e to the minus 1 times x. See? So that is our compensating factor. That's like the k is minus 1. So therefore we just need to do it in that vein. We'll get e to the minus x plus e to the plus x with respect to x. And what do we get? We get that. Do you see? See, that first term, the k was minus 1, so it's 1 over k times e to the kx, if you get my meaning. And there it is, cleaning up a little bit, minus e to the minus x plus e to the x plus c for you and me, and that's beautiful. Now, I think this is the last one, I think. If the gradient at a point x and y on a curve is 5 to the e to the 2x, that's the gradient function, and the curve goes through that point there, 0 and 7.5, we have to find the equation of the original. So it's just an anti-diff question. We've got dy dx equals 5e to the 2x, and therefore y is the anti-diff of 5 times e to the 2x with respect to x, which just gets us 5 times a half e to the 2x plus c. Now we're going to sub in our boundary condition. X is 0, y is 15 over 2, we'll get c. Therefore 15 over 2 equals 5 over 2 times e to the 0 plus c. Now e to the 0, anything to the 0 is 1. Okay, that's why log of 1 is 0, because the log is the exponent, by the way. Hope that made sense. There, e to the 0 equals 1. Okay, and therefore 15 over 2 equals 5 over 2 plus c, and therefore c is 5. And therefore our solution is y is 5 over 2 e to the 2x plus 5. Mr. Box. Yes, it's very, very mighty fine. And what's he got to say to us? Did you see the light? Yes, of course you saw the light. Of course you do. Yeah, we see the light. Now, is there any more, he asks. No, I think that's it. I think that's it, guys. I think you can stop now. You can push the stop button and be very, very happy, but you have to promise me you'll do some practice, because next time we're going to do some more, and it all builds on itself, doesn't it? Okay, well, we'll see you next time. Bye.